This is an event which we host in person in a hotel or some kind of a venue. But due to this COVID-19 situation, we could not hold an event last year, and we are holding one virtually this year. Hopefully next year it will be a much better situation, and we can go back to hosting it in person and do real networking and knowledge exchange in person. It's customary for us to, in every GIS Day event, to talk about, to actually run a video where Jack Dangerman is addressing the GIS Day events around the world and sharing his passion about GIS with everybody. So this year will not be an exception. Let's start with that. Okay, go ahead.
Hello, my name is Jack Dangerman, and it's my great pleasure to welcome you to the GIS Day in 2021. This is our 21st anniversary for this day, and its purpose is really grounded in the idea of sharing the great work that GIS professionals and our technology in our field is bringing to the world. Now, it's an amazing thing that happens every year. Thousands and thousands of people get together, they form little groups, they bring their maps, they show what they're doing, and it lays down good footprints. My good friend Will I Am says it's a time to soak it up like with a sponge and rinse it out. Not only learn today, but also share what you learn to other people. Because GIS is growing very rapidly, as we know. It's impacting almost every field on the planet. And nobody hardly knows about it compared to things like social media and the like. So this is an opportunity to share with children, showing them these professional activities that we do with maps and geographic data, and introduce also to executives and people who really don't know about our world, the whole idea of the geographic approach. Now, this approach is all about integrating layers of information, seeing things holistically, communicating more effectively with maps. So, ladies and gentlemen, thank you very much for organizing this event, but also thank you very much for coming. Many of you are holding it in a virtual environment, which I'm really excited to see. While we miss being together, this new media is allowing us to expand even greater the reach of our great work, your great work really, using geography and GIS to make a better world. So thank you. Enjoy the day.
Well, thank you, Jack. I'll start now with a little bit about the GIS as a platform. GIS has been through a lot of transformation over the years. It has now evolved into a very simple yet very powerful platform, which is simple, integrated, and open. It relies on front ends being on the normal desktop that we are used to, running ArcGIS Pro or ArcGIS, ArcMap, our catalog suite. And it has also moved into the web with portals connecting, controlling the access to either the servers or the online content which is available throughout ArcGIS Online. Sorry, okay? Yeah. Now, this integration with the web has made people who were working in silos before individually doing their own work to share their work with each other, and for the organizations to work as a integrated unit rather than individual silos. Now, GIS also now encompasses all kinds of data. We have, in addition to the enterprise data, maps, imagery, we have now content coming from a lot of sensors through various devices, and that enables us to have IoT analytics on our GIS. We can use big data, and we can even integrate social media content and do analytics on that, and many things that will become clearer when our speakers will speak later on. Let's go ahead. ArcGIS has also many applications, and this is increasing every month as we go on. Things like dashboard collector for field data collection, explorer, story apps builders, viewers, and so on are all becoming an integrated part of the apps that you can use, and you can have controlled access to these apps based on need, accessing the whole environment which is available. Now, back to the GIS Day, the previous year's focus was GIS in the time of COVID. And what we did here in Bahrain was we had a portal for with the Ministry of Foreign Affairs, and it was also linked to the global portal, which was linked, which was hosted by Israel. This year, our focus will be basically three things: real-time visualization and analytics, BIM, which is building information modeling, and integrated with our GIS, which is geographic information systems. And the third focus will be on spatial data science. Now, for the real-time visualization and analytics, you can see from this slide that the input to this is, from the left, a variety of sensors, and our GIS will then go through storage, integration, and analytics, and a whole this whole thing will be covered by our speaker, Mr. Yahya Hassan, who is the Senior Solutions Engineer with Esri Global, which is the office in Dubai, taking care of Middle East, North Africa, and Asia. The next one, which is the BIM and GIS, will be covered by Mr. Ahmed Baqiri, who is the BIM lead in Microcenter, along with Mr. Aduri Srinivas, who is the strategic projects head with Microcenter. Our third topic will be spatial data science, and it will be hosted by our engineer Ibrahim Al-Burshed from the NSSA, the National Space Science Agency, who has been diligently working with Esri technology to develop analytics like, feature identification from satellite imageries, aerial photos, things like, vegetation, palm trees, and so on. And he will enrich us with his knowledge in this field. Before I close, I would like to mention something about the organization, which is Micro Center, which we have established in 1983-84. We have several divisions now. The Micro Center core division is Business Solutions and GIS Solutions. We have Micro Promo and then Micro Center Engineering and Special Projects Division. We have Micro Training Center and QST. On the very right side is our branch in Saudi Arabia, who is doing all of these things in the Kingdom of Saudi Arabia. Now, Micro Center group, I'll focus only on Micro Center Engineering and the Special Projects Division here. We have started this in 2010 or 2011, and we have moved into high-end precision surveys as inputs to our GIS system. We use our precision RTK GPS, GPRs, ground penetrating radar for detection of utilities underground, and cable tracers. And we also have LiDAR scanners, terrestrial laser scanners. We've now moved into vehicle-mounted LiDAR systems and very high resolution LiDAR technology. With that, what we do is an integrated approach, LiDAR data acquisition followed by or with underground utility and soil profile acquisition. We can now move into mapping and 3D modeling and building of information systems, BIMs. And all of this is now integrated with Esri ArcGIS Pro, as you will see with our next speakers. The second thing one mention is about Micro Training Center, which is our training arm. Micro Training Center started out as an authorized Esri learning center, but now with the collaboration and integration between Esri technology and the AutoCAD world, which is spearheaded by Autodesk, and the collaboration of these two, we have also become an Autodesk authorized training center. One last point I would like to mention, which is the Business Solutions group within Micro Center. Okay. As a historical point, I have to mention that Micro Center started as a business solution provider, software developer with integrated accounting, inventory, and so on, which became a fully fledged ERP, and then over 4 generations of technology change, it has now moved into an Oracle-based system, which is completely cloud ready, and it has all the modules that you can see in the right side diagram, and it can take care of all the functionalities that any medium-sized enterprise needs. So this is still an ongoing part of Micro Center, And I would like to thank all the people who have been with us for the past nearly 35 years in this group. And I would like to now conclude by thanking you and wishing you a happy and enjoyable, fruitful day. And now I will call Mr. Yahya Hassan, the Senior Solutions Engineer at Esri Global, to take over the control. And Mr. Yahya, the floor is yours.
Thanks, Dr. Golom, for the introduction. Thanks, everyone, for being here. I hope a lovely, enjoyable, and memorizable, actually, GIS day, and to be able to give you a glimpse about Esri technology and how it's enabling the real-time visualization and analytics capabilities. I would like to start also to welcome all of you to our connected world. Our world has been changing over the last decade with a lot of sensors, with the Internet of Things concepts, with a lot of use cases that leverage those sensors all over the world. Some examples of those includes personal tracking, either using mobile devices or using tracking devices like bracelets for tracking pets, tracking humans, tracking criminals. We also leverage the IoT and the sensors for resources optimization, for monitoring our infrastructure, for monitoring our SCADA systems, for the utilities and electrical infrastructure to understand if there is any leakage or if there is any outages, and to be able to monitor the operations. Also, we monitor the assets and the entities, whether it's vehicles, planes, or ships in the sea. Understand if there is any hazards or if there is any delays, monitoring the real-time operations to be more efficient and to be able to take decisions the soonest. Also to protect the infrastructure by understanding the threatened areas of it, or the areas that may be more prone to leakage or more prone to maintenance times after decades of building it. Also understanding the anomalies, detection of the various data that we are getting from all the sensors. Whether those anomalies either humid areas or winds, excessive winds in specific areas or excessive heats in specific places, and to be able to understand how those are affecting the air quality, how the pollution coming from the vehicles and the density of the traffic is affecting the air quality by monitoring the sensors of the signals and understanding how many cars are there, and also sensors for monitoring the air quality and the hazard components in the air. Not only on the air, also for the soil and crop, with a lot of sensors to monitor actually how wet the land, how much solar energy does it get actually, when is the proper time to collect and harvest the crops based on those sensors. And with the new evolution of the hardware and the processing power, we also have now on the bottom right side the connected cars, how to be able to mitigate the risks of driving, how to make the driving experience more safe, more efficient in terms of the time, and understand where are the areas that we need to keep an eye on and enhance it toward a safe, lovely future. So the key challenges in all those IoT sensors and in meeting those needs to make those use cases viable is mainly the ability to, we like to be able to process those high volume and velocity data to enable the mission critical applications. And in order to do this, we would like to be able to first ingest all this data and analyze it. And based on the analysis, find out what are the things that we would like to be alerted on, what are the things that we would like to take actions on. From there, this is where the real-time visualization and analytics inside Esri came to the surface. To integrate all the sensors, networks, and in the Internet of Things platform that you have in place, whether it's fixed sensors or moving sensors, whether you have direct access to it, or whether it's a cloud IoT providers, you will be able to integrate and ingest feeds from all those sources or all those sensors. Whether you would like to manage this infrastructure on your premise, on your organization inside it, or if you need our help in managing this infrastructure, making it scalable to support those high velocity, huge data, we'll love to have this using the ArcGIS Velocity. On the premise, we provide you with ArcGIS GeoEvent Server and GeoAnalytics Server to have it in-house as you want. Having this will provide you with a situational awareness and understanding that you would like to have. You will be able to analyze real-time and historical data from the sensors and provide the proper alerts. But how this is work? This is working by having, as an example here, the ArcGIS Velocity. And you have the various sensors for monitoring the various aspects that you would like to have. You can integrate, or I can maybe get access to those sensors through the IoT platforms like Microsoft IoT platform or Azure or Amazon IoT platforms or the various IoT platforms in the market. The ArcGIS Velocity will be able to integrate with those platforms directly to get all the readings and all the live feeds from the sensors. And if you don't have an IoT platform in place and you have your own sensors managed by your own systems, we can also connect directly to those and start getting the information from there. Once we have this connection, we'll be able to get what we call it a feed. This feed is a representation of the sensor readings that we are getting. And then you can in real time analyze it, or the history, you will be able also to analyze it to get understanding of the patterns and the trends from there. Talking about the feeds, those feeds and those analytics can be exposed and shared after that with many apps and even with developer APIs or desktop applications that will allow you to visualize and analyze those even further in a more focused, specific service or industry needs. Let's start by the feeds as a first start. So the feeds are actually is a mechanism for ingesting and visualizing the real-time data from the sensors. We support actually connecting to various data sources, whether it would be coming in the ArcGIS layers or features or stream layers, or it might be a cloud IoT, as I mentioned, might be coming from Amazon or Azure or Cisco or whatever the IoT platform that you have in place. We also have web and messaging, HTTPI and Kafka and RabbitMQ and RSS ways for integrating with other existing IoT platform or system that you may have. We also have system auto discovery to understand what exactly the data on those feeds, how it's structured, what are the various attributes there and the data types. And you can use those feeds to behave like a stream layer, to be like an immediate display of all new data as it comes, relying on the concept of pushing sensor feeds rather than pulling for a real-time feeds. So the real-time feeds also empowers you with various visualization. It would be a real-time visualization, or it be a visualization of the historical big data analytic that you may have. For the real-time, it will be stream layers, which is with the pushing mechanism or the pushing data flow. You will have a really optimized network bandwidths, and for the feature layer, this is with the pulling approach if you want to adapt this one. For the historical data and the big data, we have a really optimized big data stores with map image layers that will allow you to get massive hundreds of thousands and millions of records on the map and promptly using the aggregation methodologies on hexagons or various pixelation methods. So let's have a glimpse on this and see it in action for helicopters operations and how we process the feeds. This is in the North Sea, and what we are seeing here is the helicopters movement and the various airports or the various destination points. This is actually a fleet, helicopter fleet for an oil and gas company. Here we'll be able to get information about each helicopter, the timestamp of it, and the various readings about the destination and where it's coming from. So the idea is here, how can we actually configure such thing, or how can we be able to benefit from such information? So the ArcGIS velocity here allows you with his three fundamental components of the feeds, real-time analytics, and big data analytics to go to the feeds and pick how you would like actually to ingest the data, whether it's on the ArcGIS or on the cloud, like the case we have, or web and messaging, or various data providers like Verizon or Geotab. So there is a lot of options here based on the feeds and the IoT platform that you're integrated with. So here in this case, we'll take the web and messaging. And as you can see inside it, there is various ways for actually the integration. We decided for this one to take HTTP connection, and it's mainly there is no authentication type, so also keeping an eye if it's secured infrastructure. For the scheme, we have also auto discovery capability that allow actually the ArcGIS velocity to pull a sample of the data to understand what exactly the scheme by just pulling those sample. By discovering the scheme here, it will provide us actually with what exactly the data is coming, what are the fields are coming, what is the field types, the names, and the various sample of the range and the values that's coming. We can change the field types as we want, or we can ignore any of the fields if we are not interested in any of them. I can move forward to start also defining where actually the location fields are. Here is X and Y. Also the date and time, are there any date and time field that we would like to have? So we have a timestamp here. And we also take the look to the formats, how it's structured. And eventually the track ID, which is an identity of the helicopter. The feed name, just define the name, and now we have this feed. We can see all the details here coming, showing us actually the various details that we have just configured for this feed. By just having this, now we have a live stream, and as we can see it here on this map, showing this information of the all helicopters as they are moving in a simple web map that we can use it across the ArcGIS platform as you want, whether it's in mobile devices or in other web pages or desktop applications with the various capabilities of the API. Moving forward to the next element, which is real-time analytics, which is mainly for processing and analyzing the real-time data streams, which is the feeds. So the flow here is we provide you with a way for configuring the pipeline of the analytics that you would like to apply to all the feeds as it comes. And the outcome would be either a feature layer for visualization or even further monitoring, or it would be a notification, or it would be an activation of other systems to take action as needed. So the real-time analytics process and analyze those real-time data streams by having a definition of the input sources that would be the feeds that we mentioned, or it would be static data sources that we can add. Like, for example, in the previous example, the airport, because it's a static data source. We can define those as an input for those real-time analytics. Then define that using the analytic tools, we define the pipeline by just stacking the analysis that we would like to have one to another, and managing the connectivity between them to analyze individual observation that will eventually provide us with an output that would be a layer or an alert or notification through an email or SMS or an activation of other systems. There is a lot of inputs and feeds supported, as you can see here in this slide on the left side for the feeds. Those feeds, the sources of them would be coming also from various sources, as we mentioned. It would be from Amazon, from Azure, from even a public website with the polling technology. The outcome, again, would be an ArcGIS Esri platform thing, or it would be another IoT platform. So we can also send the outcome, the output from those real-time analytics back to Azure or to Amazon or the Azure IoT Hub or the RabbitMQ, or send it an email or text message. We also support a wide variety of formats based on your needs. So let's see, again, continue the same example for the helicopters operations and see how to have the real-time processing and alerting configuration put in place. The objective here is, rather than just seeing the helicopters moving, is to add an insightful value from this. which is defining or finding out the estimated time of arrival for each helicopter as it's traveling from its own airports. So here we have the helicopter as we are seeing on the left side for the left box as an input. And we have this tool for calculating motion statistics that will allow us actually to get the average speed, the distance, the total distance, the minimum distance conducted, the height of the elevation, the slope, the various motion information as it's coming from the sensors. We can process all those sensors reading as they're coming and calculate those motion statistics in place for a better understanding of how fast or how actually is it moving and is it getting height or losing height. And then we calculate the distance from the helicopter destination, and here we do a join with between the destination ID and the static layer of the destinations of the airports. Then we limit this to a 300 miles. This is what we would like to focus on, and would like to get about the airport, the status of the airport, the type of the airport, and just an idea of the airport to be also enriched of the feeds coming from the helicopter. And then we start mapping those fields based on our needs here to have those whole list of the feeds. This will allow us actually to add even additional fields using a simple arcade expression. It may look a development thing or an IT savvy person, but it's pretty straightforward. And even here, so we would like actually to have a better representation of the distance or estimated time of arrival. So we can actually here see the distance by the airspeed, a simple expression. Just if you know the equation, you'll be able to pick the field from the feature and just have it in place ready for you. And now you have an additional field for the estimated time of arrival. Here also we built a little bit more advanced approach, so to have this in a friendly way or in a friendly text. This will allow to interpret the estimated time of arrival rather than to be a number, to be a text value. So the outcome here will be this string, as you are seeing, estimated arrival is in 1 minute. So this is an example, so you'll be able to see examples from the arcade expressions as you are defining them. So here we define those fields, and we can also see the outcome, which is a feature layer. Again, we can use it also in web maps or in whatever place that we would like to have. The red ones here are the ones that we have just enriched with the estimated time of arrival. By just clicking on any one of them, now we have a more insightful information. We know the destination, we know the estimated arrival time is in 48 minutes, and we also have motion statistics about the current speed, the distance to destination, and the timestamp effort. So this is how you would be able to leverage the RGS velocity by defining this pipeline of analysis tools based on the real-time feeds. This is not limited only to simple analytics. We can also apply geofences to understand the distances. And let's see also another example for applying dynamic geofences here. Rather than talking about the flights or helicopters, let's go to the land here. And in the land here, we have this AVL tracking system with all the AVL tracks as we are seeing here that we just defined its feeds to have all the information about the vehicle. Zooming in, we will be able to see them moving flight, and this is in the area of Houston. So we would like to also to understand, are there any hazards on them or are there any threats on them? We can leverage this by also integrating another feeds coming from another partner of Esri called Data Miner, which is provide threats actually across the world, whether it's political threats or also it would be any major threats or disasters that would be happening on the world. So let's here see that those dots in yellow, those are the Data Miner feeds, which is a representation of those threats. So we would like to understand if any of our fleet getting in proximity to those threats. So in order to accomplish this, we would like also to build a buffer around each one of them, and then later we'll be able to have also defined an expiry of the threats. The ones here, as we are seeing here in gray, are outdated threats. So we need to ignore them and just understanding if there are any risks or any hazards on our fleets, because those are outdated already. So we'll be able to filter this and define all this to identify which are the vehicles that we need to keep an eye, and maybe provide some messages and emails to those drivers to understand the critical situations that they are in. We start doing this by going to the RGS velocity and start defining all those steps one by one. So let's go there and see it here in place. So here we have, as you can see, the tracks on the left side for the vehicles on the bottom, top left, and the second one on the left is the data miner events coming, which is the feeds that are coming, includes the location. So the next thing is we would like to enrich all the vehicles with the nearest event that might be threatening to them. And in order to accomplish this, we had this calculate distance tool, and it will allow us actually to define the spatial relation that we'd like to have, which is a 500 meters filter to the data miner events, and also would like to only monitor the last 10 minutes threads, not all the threads. And the output we can define to be the distance in meters. So here we defined our thresholds and our parameters that we'd like to include. So now the outcome from this is a feature layer that only shows the vehicles that the vehicles with the nearest events to them, if any, providing that those events are within 500 meters and within 10 minutes. Next, we'll also define whatever the fields that we would like to have, and here we would like to get an alert to include also what are the threat category, whether it's political or disaster, and then start filtering all those vehicles that we need to focus on. The outcome here will be actually various feature layers showing us the history of vehicles that was under threat, as well as the live ones, in addition to also to the vehicles within threats, with a line actually showing how far actually they have been in threat. Let's get back to the map and start switching those feature layer outputs that came from this analysis. And this is live again here. So we'll be able to see now first the buffer that we created for 500 meters. Let's switch first all the layers, and then let's zoom in on one of the areas to understand actually where are they. The ones in red, by the way, are the ones that under threat. So as you can see here, we have the buffer of the 500 meters created for us. We have the line, yellow line, showing how far is it from the event, and it's showing the close events. As it moves, you will notice that it will not be red anymore right now, and you'll notice also there is a gray one on the northeast side, but it will not provide any alerts for it as it's getting close to it, despite that it's within 500 meters, because it's already this event past the 10 minutes threshold that we defined before. So this is an example of how to apply real-time analytics using the RGS velocity. But the next will be, it's not only about the real-time analytics, also about the ability to create the same analytic pipelines like we did for real time, but on the historical data. But the historical data will be massive, billions of records of data that we'd like to analyze. So the RGS velocity allow actually, in addition to the real-time analytics, also to store all the historical records, to keep it all in feature layers, and then use big data analytics with the same approach like the real-time analytics to create pipelines like the ones that we are seeing here on this slide here. You'll also be able to define the inputs, and in this case will be either feature layers or S3 buckets on Amazon or Azure blobs. So this is a historical data places for massive big data, and you'll be able to ingest it, not as a real time, but for analytics purposes, to apply analysis patterns and find locations and summarize the data. So those big data analytics. You can run it only once, which would be great, but in some cases you may also need to run those in periodical for maybe every few minutes to summarize the data because there is massive data coming, or every hour or overnight, or maybe it's a recurring thing every day. So you will be able to also define the frequency of the updates. So to wrap up, this is how the ArcGIS Velocity was able, as a real-time and big data engine on the ArcGIS Online, to ingest the real-time feeds, analyze it in real time or in historical records, and provide alerts and messaging. This enabled various capabilities, including the ingestion, the visualization, applying geofences, detecting incidents, understanding the trends of the big data, and providing alerts as messages, as well as emails and various other ways for actuation of other systems in place. The ArcGIS Velocity is a SaaS offering. It's a cloud-based. It's already configurable for user experience and guided, so no development requires are there. And it's managed by Esri, so it's scalable, and it will eliminate the IT staff configuration and maintenance that would be needed of the infrastructure. But at the same time, we do also have real-time visualization and analytics available for you on-premise through the ArcGIS Geo Event Server and the Geo Analytics Server on the ArcGIS Enterprise. This is for on-premise users and for savvy IT guys who actually would like to manage everything by themselves, or if you have a closed environment that you would like to maybe to extend it with those capabilities, or maybe if you would like to do some extra development into the intercommunication of those real-time feeds. With that said, thank you for your listening and being here with me, and hoping you an enjoyable event. Thank you.
Thank you, Mr. Yahya. I would like to introduce myself. My name is Ahmed Baqari. I'm the BIM leader in Micro Center, and I will start talking about BIM and GIS integration. Building information modeling is a digital representation of physical and functional features of a building. It allows engineers Building information modeling is a digital representation of physical and functional features of a building. It allows engineers and architects to design building and model structural MEP, and even sustainability data. Now, with the help of BIM, engineers and architects can collaborate on the ArcGIS, GeoBIM, and Autodesk Construction Cloud platforms. Now, integrating BIM with GIS allows planners to explore a model of a proposed building site, identify such as infrastructure or landslides, or examine current conditions such as topography or access roads, or even for the urban planning. When it comes to the 3D data acquisition, it is essential to obtain input data to generate a BIM. But when it comes to generate a detailed BIM, then indoor and outdoor scanning is essential. Why it is essential to apply indoor scanning? To generate a BIM model from the architectural indoor for a building in its MEP. And outdoor, it's essential to generate the outdoor architectural and structural part of the building. And we can obtain these data through point cloud and panoramic images as demonstrated in the below picture. You can see in the below diagram about the high-level 3D survey process flow, which starts from receipt of a building layout as input data, where we collect as-built drawing in EWG format, and etc. Obtaining requisite permission and scope analysis, which is the permission to do the survey for the given area, objects, and building. Therefore, we can analyze the scope of the project, where we visit the site and plan the 3D survey execution. Data acquisition for indoor and outdoor, as mentioned earlier, to generate a complete BIM. After scanning, we need to process the data to generate a point cloud. Then with the help of the point cloud, we can start generating Revit model for the scanned building. Then we can develop geospatial web application. Then finally, we can hand over the solution to the customer. For 3D mapping in digital twins, meaning the physical representation of a building, we can collect the data based on the client business requirements, as shown on the screen, with different kinds of methods. Now, for a larger area, we can either go for the drone mobile mapping or vehicle mobile mapping. But when it comes to scanning areas that neither drone or vehicle mapping can't access, or car-free cities or alleys at times, we can go for the backpack mobile mapping. And for the indoor and outdoor, we can collect the 3D point cloud data through spatial radar, such as power laser scanning. The screen about an evolution of mapping starts with 2D maps, going for the panoramic images collection, and further developing reality BIM model. And finally, we can build digital twins, meaning the physical representation of a building. Now, after collecting the point cloud data from either the mobile mapping or spatial radar and process it, we can generate BIM model with the help of point cloud. Now, what is a point cloud? Point cloud is basically a 3D representation of physical object of whatever the 3D scanner captured. The below shows a point cloud of a scanned indoor building, and we can see on the left picture a Revit model generated from the point cloud, and all features are designed as the actual model. When it comes to BIM and GIS infrastructure projects, Autodesk Naviworks 4D is a BIM software that enables engineers to visualize 3D information in a 4D space, which can help architects and engineers create better designs. Now, BIM and GIS are two important concepts in the world of infrastructure projects. They both aid in the decision-making, project planning, and execution to make the construction process smoother. When it comes to integrating BIM and GIS, designers, engineers, project managers can utilize Revit, InfraWorks 4D, and Civil 3D softwares. And using these technologies, we can go through Autodesk Cloud Platform and BIM 360. We can take all the inputs and transform from Autodesk Cloud Formation to ArcGIS Online Cloud Platform as an integrated component of BIM and GIS solution. And now I would like to hand it over to our head of strategic projects, Mr. Adori, where he will talk about the future of BIM and GIS.
Thank you, Mr. Ahmed. I'm Aduri from Micro Center. Good morning to all of you. Thank you for your time today. I'm working on strategic projects in Micro Center. So today I would like to discuss about future of BIM and GIS as a GIS and BIM integration part. So I'm talking about this slide about the future of BIM and GIS. So BIM and GIS integration is a major leap in the world of architecture and construction. The two technologies work well together because they both share a common purpose to provide accurate information about the buildings and their surroundings. BIM and GIS integration improves the accuracy of architectural models. This leads to better decision-making process throughout the building process. So therefore, BIM and GIS integration also creates an efficient workflow for architects because It eliminates redundancy between the BIM models and the data collected from GIS system. So BIM and GIS are two different information technologies that combines to make a construction process more efficient. They both allow the data sharing and communication between the designers, engineers, contractors, clients, etc. So I would say that BIM and GIS can provide a foundation for spatial management. This slide we are talking about BIM and Revit model, how we can able to bring entire the data, from Faro survey, even developing the BIM and Revit model, and how do you bring from Autodesk platform to ESRA, RGS Online or RGS Enterprise. So this is a continuous system. For example, if you look at the left side screen, the Revit file, it has a layers. For example, if you see the walls, doors and windows and floors or whatever. So as explained by my colleague previously, Mr. Ahmed, basically this survey is very, very important in terms of collecting the point cloud data using the Faro instrument or whatever. So that point cloud data has to be processed because it is a beginning, it's in raw data processing, and then we can convert it to the, in a Revit model using Autodesk Revit platform. So taking the Revit and on top of it, we can also, based on the client business requirements, we can have a more advanced engineering, the survey using Autodesk Civil 3D. For example, if you go for larger infrastructure, we need to collect in advanced surveying data, So therefore, Autodesk Civil 3D is an additional component along with the Revit. And Autodesk Naviworks is a fourth generation where you have time schedule. For example, if you want to construct the building, it is an infrastructure, right? It has lots of material, management, time, cost, budget, lot of things. So it is a component of a 4D survey. 4D is an additional on top of a 3D and as a time management. It gives a business decision making for the customers, for the investors. So bringing the Revit as well as Autodesk Civil 3D and the Naviworks, we can push directly into the RGS Pro. And RGS Pro is an ESRA platform. And if you can look into the left side screen, I have specified about the scene layer types. So once you convert the Revit file, it's in a bars. And so this is called a levels. In Autodesk, we'll call it as a levels. So these levels, for example, floors or whatever, it will be converted into 3D objects. And it comes with the point cloud data and building scene layers. So converting is directly convert that the Civil 3D or even Autodesk or Revit models into RGS Pro as a scene layers. So it will become a scene layer packages. Now, what is a CT engine? CT engine is a most advanced 3D CT modeling. You can build a larger extent of, for example, for city and urban planning purpose and for the landscape also. So having that building information system with the component of Revit, Autodesk, even Naviworks or whatever, and CT engine will give as an additional advantage to bring as a scene layer package. Then we can push it into RGS Enterprise to build web-based application. Either you can put it on. So then finally it will become a scene layer as a web scene. You can push it on top of RGS Online and as well as even RGS Geo platform. That we'll discuss in my next slides. So as I explained in my previous slides, the CT engine is a 3D CT modeling and RGS Pro is a Revit model and 3D scene layers. There is a screens that have been shown here. Now coming to this next slide, we developed to one of my client, like 2D and 3D, okay? But I'm not talking much about this project we developed for Babco here in the local customer. But this is interesting that since we're talking about BIM and GIS, so I'd like to bring you in your for your information, we developed apart from the 2D, advanced technologies, we also built like a 3D visualization analysis for subsurface facilities on cut fill analysis, elevation profiling, slope analysis, and exclusively even for viewing well trajectories on a 3D map, because this is very important for the oil and gas sector. So viewshed analysis also. So now if you look at the database platform, it is being developed on top of even RGS JavaScript API 3x and as well as 4x, because JavaScript 4x supports more on 3D, 3D development, 3D visualization, whatever, and can enhance the functionalities. Now, As we discussed earlier, RGS Enterprise is in the technology. We can develop 3D GIS web development for housing and land registry for building information modeling. Excuse me. So if you look at the left side screen, it's a 2D parcels, and it has the owner details, the parcel details, and the property of the parcel, and the property owner name. So it's some sort of a demographic data, exclusively for the landowners. So we can transform the 2D maps, for parcel mapping, with respect to the land registry and building. We can transform the 2D parcel data into the 3D maps, using RGS Enterprise applications. And we can create a 3D mapping. I just want to show here, 3D web editing. And you're all known that even 2D parcels, we can modify the geometry. For example, if you want to, modify the polyline or polygon, whatever in the geometry, in the 2D area. At the same time, you can also, do the web editing. I just shown one screen here, web editing in 3D. So you can edit the scene layers. For example, the same parcel, whatever shown in the left side screen, the same parcel also as a 3D, you can edit the building geometry. And you can draw the lines, you can digitize the lines, whatever. So the technology I've mentioned here, like in RGS Enterprise 10.9.1, of course, it is released just a couple of days before. And we can develop even React.js and even RGS API, the platforms. But the BIM 360, Revit model is very important, is a primary requirement, from the beginning to transform from 2D to 3D. So that come along with that. So that is what we have tried to show on the previous screens, transferring your 2D maps to the 3D maps. Now, see, this is another, another 3D, ESR GIS web development for viewing, analyzing and BIM models. And we can also make some sort of an query, okay, and analyze that. Even if it is a 3D models analysis also, we can develop. So here, I would like to show you a video here for a few minutes. So this is we developed one of the university in Saudi Arabia. Now, if you look at this screen, it's been built on top of RGS server, and this is we did for even a 3D survey and created a BIM Revit models, and you can also see the see now currently it is going on the slicing. Okay, the slicing is nothing but you can see the inside the objects and even external and then outside also. So this kind of slice analysis. Slice analysis also at a time you can view inside the door and even outside the door as well. So you can visualize that because it's a BIM component, right? As a Revit model, we can able to view the inside the building or outside at a time. Parallelly, we can view that. And now here you can also this is a 3D scene layers as I explained in my previous slides. You can also measure the distance and calculate the area and even the geometry, which I'm talking about, the area and dimensions. Okay, so the second thing is that, and you can also have a buffer kind of tools, and you can also have a print. And if you can see the layers here. Okay, this is an interior you can see, and even exterior panels and point cloud data. Now here we are trying to show here. This is an HVAC, means heating, ventilation, and air conditioning. This is an indoor mapping. Okay, so you can view indoor and as well as even outdoor. For example, measure the distance. So this is HVAC. I think you know that HVAC is for heating, ventilation and air conditioning as a technology for the indoor and vehicular environmental comfort. So this is also we can develop as a part of BIM models. So point cloud data is being added on top of it. We are working with our technological partner Genesis here. So now you can see the dashboard here. You can see the total length of the area, road length, and HAS reduct, and the number of doors and controls, and number of fires and windows as well. So dashboard analysis. So as I said, it's been built on top of ArcGIS server, and using 3D scene layers, also having web editing. You can create a complete dashboard analysis based on the client business requirements. Now this is, I'm going for this again for ArcGIS Urban. So this slide is again a web-based experience. It's designed to drive for the smart urban planning and development. Okay, so ArcGIS Urban is a GIS mapping which has been developed by the ISRI. So it provides a map, data, and geographical analysis. It helps understanding the needs and challenges of the urban planners and the local governments and designers. So ArcGIS Urban is an extension of ArcGIS platform. This extension provides as an web-based interface for accessing the data, tools, as well as designing the environment for creating a sophisticated maps and visualization. And you can also understand the population patterns and distributions so that we can combine different data sources in order to enhance their understanding of city performance in depth. So what I would like to say here, see the ArcGIS Urban allows you to visualize the city plans and projects in one place for collaboration among the stakeholders. Now, before building this ArcGIS Urban, we need to have the data sets. This is very, very important because without the data we cannot go. So we are trying to classify here like in space types and zone types of kind of. So this data has to be come from the customers, and we can also develop the data model and data migration because the customers might have different kind of databases and that has to be taken into the their considerations, and we need to enhance. And second thing is that we need to enhance the data, and we can able to develop the ArcGIS Urban models to the customers for city and urban planning. So that itself makes some smart urban planning and for the development. So the technology stack is also mentioned here. So this is an ArcGIS platform as an extension of ESRI. ArcGIS Indoor, here we're talking about ESRI ArcGIS Indoor. Like before talking about this ArcGIS Indoors, we know that outside we are familiar with the GPS. We are very much familiar with the GPS for the outdoor tracking. But what about indoor? So here where this ArcGIS Indoor comes for the facility management with IoT. So as I said, we are familiar with the GPS outdoor, but indoor we need to have some technology where we can bring ESRI ArcGIS Indoor for facility management with IoT component integrate, and as well as ArcGIS IPS for indoor positioning system with the beacons. So ArcGIS Indoor platform delivers a real-time facility awareness and drive Internet things systems and provides analytics that help you, elevate the experiences of your staff or your visitors. So using data from sensors and facility systems and facility databases, we can build an enterprise present insightful performance of any information on dashboards as well. So what I would like to say here, ArcGIS Indoor is connected to an indoor network via web maps, visitors and maintenance workers for smart routing to navigate the buildings. This can be well managed with the environment, keeps them focused in a productive manner. Now, we also try to show here, ArcGIS IPS. The IPS is available for ArcGIS Indoors, and it runs along with the ArcGIS runtime SDK as well, which enables you for the indoor positioning capability in custom builds. Okay, so ArcGIS IPS allowed you to collect radio signals from Bluetooth low energy like BLE. Okay, and here like ArcGIS IPS is required. Besides that, you need to have for ArcGIS IPS you need to have a beacon. So beacons is an inside buildings to enable the indoor positioning system. So beacons is a radio station that broadcasts a directional signal for navigational purpose. because we're talking about, see, it could be the inside that airport, inside the complex, big complex, city, the big complexes. So for newcomers, having that IoT system integrated with the RGS facility management and positioning system where the person is staying. So using that beacon, radio signals, it will give the the position of the navigational purposes. So we can also use that RGS IPS as a geoprocessing tools that also used to include to set up and author your IPS environment in RGS Pro. And downside the screen, if you look at that, again, it has come with the BIM to RGS indoor data sets. So BIM is a main component because today we are talking about BIM and GIS, So BIM is a primary requirement to bring entire the system into the RGS data sets. So here we try to show here, if you look at the screen at, that indoor information model, here again, we talked about, site, facility, level, floor, building, zones, types, and everything. So this combines, it comes with the bundle of Autodesk from Autodesk platform as a Revit, okay, in terms of a layer, as I said earlier, converted all these things to scene layer. So finally, it will become a 3D buildings and scene layer. So even in the RGS indoor facility management system, we can have a 3D building layers and scene layers as well. So the left side, we talked about the, the technology stack like a BIM 360, RGS Pro and City Engine, based on the client business requirement. So stakeholders can view the facilities, includes the aerial, indoor and outdoor views, and it also gives the more advanced, like a query search from this guy from one location to another location inside the facility management, and also from one building to another building, using the facility management and the IPS system that we can develop. Now, this is, I'm talking about RGS GeoBIM. This RGS GeoBIM is recently released from ESRI. It's a new product. It covers, so see, RGS GeoBIM is an extension to the geospatial technology of the ESRI ecosystem. RGS GeoBIM is a powerful software solution that you can help to get most out of your building information modeling, and RGS GeoBIM can leverage the power of RGS Pro and RGS Enterprise and RGS Online. So RGS BIM allows you to analyze spatial data in context of topographic maps and 3D building models and visualize the models. So what I'm trying to say here, the RGS GeoBIM can be as an innovative web experience to explore, and we can collaborate between Autodesk Cloud Platform to the RGS Online platform. This is an integrated component which is recently released from ESRI as an RGS GeoBIM. Now, if you look at this RGS GeoBIM, it enables the linking of projects and workflows, as I said, by connecting the RGS with Autodesk construction platform. Now, if you look at the left side screen, this is a building, fine. This is an RGS GeoBIM environment. So if you look at the left side screen, click on the scene object. If you click on that, extremely right side, you can able to view at a time the Revit model. You can see the Revit model, the details in terms of the dimension, whatever you can call, in terms of what is an objective and what is a kind of category and what is an element and everything. So actually the Revit model, which I'm talking about the right side, that has been bring from Autodesk Cloud Platform. Okay, so this is played on top of RGS GeoBIM. So the AEC people, at a time they can view both geographical location with respect to the Revit model on the same screen using the GeoBIM platform. Now, this slides is as I said, is a cloud integration component between Autodesk Cloud Platform as well as in RGS, GeoBIM. The left side is we have been shown like a building, and right side we can see the Revit drawings as well. For example, if you take the building here, right, the right side is a Revit model, but the architects or even civil engineers, they given the drawings to the what you call it, to the IT companies or someone, right? So how they will compare it? What I'm trying to say here, the Revit and DWG drawings also you can align at same time on the left side screen on the GeoBIM environment. it should exactly align on the same, including the floor plan, including the total building measurements or whatever. I'm talking about apart from the asset details, apart from the asset details also, you can view and align on your side, the align along with the GeoBIM map also. So it will give the assurance that exactly what architects has given the dimensions about the building in terms of dimensions or whatever, you can see in the left side screen as well. Now here I would like to show, this a small video here. Yeah, this is an ArcGIS GeoBIM. Previous slides have been shown here. Now again, I would like to show here. See, this is a BIM and GIS integration. As I said, this is an ArcGIS GeoBIM platform, and you can view, the geographical locations, exactly the building or even different objects as a scene layer packages. Okay, so if you click on that, and you can see exactly, the Revit model. Now, how it is happened, we need to put your all Revit model, Revit drawings, even Naviworks 4D, even documents and everything that has to be kept ready in the Autodesk Cloud platform in the BIM 360, right? So you need to push the entire the Revit models and the components from BIM 360 platform. And as I said, like an Autodesk cloud platform is there. So that is a cloud platform. So from there, you need to push on ArcGIS Online platform, because ArcGIS GeoBIM is reside on top of ArcGIS Online. So that is the reason why you can able to view on the left side the geographical location of the buildings, or even city planning or urban planning. At the same time, you can also see the architectural concern, because the GeoBIM talks more about the AEC, for architecture, engineering, construction. Now you can see the location of the building as well. So this is a combining package of both 2D and 3D for even asset information, building location, and you can able to visualize the information about the AAC. Now, what is an advantage of going for this GeoBIM, like GIS and BIM technology? This is a more advantage for the IT professionals, and as well as for stakeholders, for for sort of taking any business decision making, customers, and even governments as well. So geospatial applications is more good for the operations and maintenance, and for the main management activities. Now, finally, this is what are the applications we can build? Yes, see, for ArcGIS Urban, we can build BIM and GIS applications for urban planning, housing, and like as I said, housing and building information, and even GIS facility management system, architecture, utility mapping, and IoT as well, even 3D terrain mapping and telecom and railway corridor mapping. So thank you for all of you. Thanks for your time. Now here I would like to introduce Mr. Ibrahim from National Space, from NSSA. Is a lab manager. Is a National Space Science Agency in Bahrain. So he'll be talking about on spatial data science. I would like to hand over to him.
Thank you, Mr. Adori.
Yeah, thanks, Mr. Ibrahim. Thanks. Yeah.
Let me share my screen. Okay. Okay. Good morning, everybody. This is Ibrahim Al-Barshed. Today I'm representing the National Science Space Agency in this well-known GIS event that happened every year. Many thanks for Micro Center to give us the opportunity to be in this event. The title of my presentation today is the use of remote sensing and artificial intelligence to meet the National Space Science Agency lab objective we have two teams in National Space Science Agency. Today, I'm only representing the team that are responsible for data analysis using satellite imagery and data and space data. Starting, I will give you an introduction about National Space Science Agency, since it is a very newly established organization, starting from His Majesty vision to promote Bahrain to a position of international prominence in the field of space science for the purpose of achieving comprehensive and sustainable development. The subordination of first of all, the National Space Science Agency is established in 2014. It's almost 6 years from now, or 5. Transfer to Bahrain Defense Force, then to Ministry of Telecommunication, and then the subordination transferred to the Supreme Council of Defense in 2021. The national NSSA goals for 2019-2023 is to promoting space science through the awareness session, like today's session, to construct a sound infrastructure regarding the space and the ground stations, to encourage the kingdom to be part in the international agreement, to respond to the national requirement through provide space information and Earth observation data. And this is our goal today, to cover this point, and to build a national capacity for our national employee. NSSA service, since it's provide satellite imagery data to analyze the data and to provide a printable image that can be used in the text box and other things. Starting from space, this is our Earth, and you can see there are a lot of Earth observation sensors. Today, they collect a very big data to our plants, and maybe around 1,000 of sensors collecting data. These data should be transferred to an information, and this information should be transferred to a knowledge that can help the decision maker to make the decision on the right time with the minimum cost. I will start to give you a brief about EO data sets, give you an insight or snapshot of remote sensing. There are a lot of EO data sets available for open source and other for commercials. Okay, starting from aerial camera, multispectral satellites, to radar satellite that have the ability to penetrate the cloud, and then this is the promising and the newly sensor that hyperspectral. It gives you the ability to capture the full range of spectrum with the very narrow bands, and many and you will have many bands in your data set. And all of these sensors have different application. You need to select the sensor that fits your applications. Okay, I'll give you satellite imagery characteristics, and this is our aim in lab, is to transform this satellite imagery to an application that help the citizen and filling the gap information in the Kingdom of Bahrain. So what's the information that I can have? I'm answering every day, what's the information that I can have or generated or extracted from this satellite imagery that help Bahrain citizen? The characteristic of satellite imagery is covering a wide area. You can have a lot or many frequency that you can, for example, one of satellite provider company can capture Bahrain every day. So if your application is required from you to monitor the location for every day, you can do it easily by satellite imagery, and a lot of application that can be done through the satellite imagery. There are other sensor that can you provide with other data, not satellite, not image, like data regarding the X gamma and for example for air quality they give you like concentration of CO2 and similar things. Okay, due to the short time from 2018 to now, I think three years, we did some of application in our lab, starting from surface temperature analysis to monitor the agriculture in Bahrain, to object detection of the palm trees, for the oil spill as well, for the ship detection and air quality, soil classification, building change detection. We have the ability and we have that trained team that can deliver based on governmental request a lot of application, as you can see, and we did like a pilot project in different domain of applications. I will give you like a historical data about classification, since it is one of the major application in the remote sensing. Traditionally, we used to classify the satellite imagery based on pixels. So every pixel can only be classified by one object, either it's a building or roads or anything. This is called the hard classification. And then newly, I think there are others like soft classification, which use the fuzzy classification that can give you like in each pixel can be classified based on multiple class. This is a very huge and development in the field of classification. Then the researcher moved to the object-based classification, which is we end up in pixel-based classification in here. Then they moved to the segment and thematic map. As you can see, the difference between pixel-based and object-based classification, that there is no, they call it salt and pepper in the object-based classification. And still the development in this field is promising and have a lot of data. The advantage for the analyst is to have a quick solution with the highest accuracy that you can map, for example, the Bahrain with the few of clicks or without the need of many employees. Just imagine this is not only for Bahrain or any place that you are interested in. We did an image classification and prediction, which we used the northern governance as a samples. We transfer, as you can see in your left hand, from an image to a map that consists of 4 labels. And this 4 labels, we want to study how the interaction between the urban area and the agriculture area. And we did like classification for 3 years, 16, 18, and 20. And then based on the AI and based on AI models, we used to transfer or to predict what will happen in 2020. As you can see here in your right hand, there is a huge development will be in 2030, especially in the southern area of the northern government. This is just like an application, how you can, what's the benefit of image classification, that you maybe for the decision maker can put regulations and or rules that and they did for now. I think all of you know about the initiative Pioneer, that they start to plant a lot of agriculture in the area to preserve this area from decreasing. Then I give you another example of object detection using the deep learning. There are, and this area is a hot topic and trend in the remote sensing community. They are trying, due to the very high spatial resolution in the market. It was 31 centimeter per pixels, but now I think there are more than that, maybe 25 centimeter. I think Indian satellite imagery. So due to this, the achievement of the ability to capture satellite imagery with a very high resolution, there is a good opportunity for using or integrating deep learning in order to detect any object that you are interested in. By using the deep learning, you train the machine to detect these type of object, and once you detect the object, you need to delineate it, and then you can categorize it through the GIS environment, and you will have a very updated and recent data about the area that you are interested in. And we did similar with the help of ArcGIS and deep learning using Python. We did we are interested to have a request from other government entity to know about how many palm trees in Bahrain. We check this methodology and we get a very good result. As you can see, we are able to detect the palm tree, the whole palm trees in Bahrain using the satellite imagery with the help of deep learning. And we manage also to assess every palm trees in your right hand using they call it a vegetation index. So this is a very good application that can help the farmers to know about the health of their plants using the geomatics application. Just technical analysis of geospatial solution regarding what's the added value of doing deep learning. As you can see, if you are going to do the manual, we estimated you will need 5 members for 4 months to do the manual recognition, while in integrating the AI, you will have only 2 members with 2 weeks to 2 hours that they can detect all and find a solution for your problem with the very lowest resources. We did also an economic analysis for our geospatial solution for project A, as I explained to you, and for project B, and using the benefit cost ratio. And we find we collect the amount that need to be spent for each project and what's the benefit for each project, and we run this project for 10 years from 2020 to 2030, and we get a BC ratio, which is the benefit cost ratio, 1.23 for the project A, and for the palm trees is 2.1 0.19. What's this mean? This means that you spend every 1 BD, you will get 1.23 BD as a return. And you can see also for palmetries, instead of doing it manually or doing it by using a GPS or any other method, this will give you, if you spend on this technology one PhD dinar, you will get almost the double, which is 2 PhD dinar as a return for your investment. This is I think, the end of my presentation, and thank you for your listening.
Thank you, Mr. Ibrahim. Yeah, thank you, Mr. Ibrahim, and we are thankful to NSSA and NSSA team. So now we'll talk about spatial data science in the continuation part. So for next 10 minutes that I would like to discuss on this. So we are discussing today about the the spatial data science for population and demographic statistics, using for statistical data visualization. So the spatial data science allows analysis, to extract deeper insights from data, using a comprehensive set of analytical methods and spatial algorithms, including machine learning and deep learning techniques. So geospatial data science is a subset of data science that focuses on the spatial data and its unique techniques. Now we are talking about the population and demographic statistics. So machine learning can be used to give a high quality estimations of the populations as well as the demographic and that those populations represents. In the past, census data is the main source of information for GIS analysis. Now that there is a new generation of machine learning techniques that can process a large quantity of data and find patterns in it. Like GIS analysts have access to more data points ever before. So now the machine learning and deep learning techniques has become a very important component for the governments in terms of for more demands for the data science services. They are really increasing, turning on data-driven decision making. Just rather than using I'm talking about the demographic data analysis rather than the census data. Machine learning given larger impact for quick decision making. Now I'm talking about the data sciences. For the demographic and population analysis, what are the stages? There are 3 stages I have mentioned here. One is data preparation, analysis, and dissemination. So here, the data science refers to the process of extracting knowledge from data and extracting insights. This field includes several disciplines, including statistics, data analysis, information retrieval, pattern recognition, and NLP, like natural language processing. So machine learning is a subset of data science that relies on the algorithms to learn the data and make a quick decisions, for predictions based on the patterns and found in the data. So spatial analysis is a type of machine learning that can be used to analyze geographic data and make predictions about the future events in a given area. What are the future events? Okay, for example, the demographic analysis in terms of population. Okay, so what I would like to say here, the machine learning and spatial analysis are combined in geographic analysis so that we can see the spatial patterns, including with the GIS technology. So these are all the stages for data preparation, analysis, and disseminations. Now here I would like to talk about the RGS notebooks for spatial data science. Now if you look at the screen here, we have mentioned about API designed for data science. What is an API? RGS API for Python is a library for performing GIS visualization and analysis and spatial data management and GIS administrative tasks to run both an interactive fashion and using the scripts. So RGS, notebooks built on Jupyter notebooks for open source web application that allows you to create and share the documents on Python coding, visualization. For example, now we are talking about demographic, right? For a statistical visualization, RGS Python, RGS notebooks play the major role for the spatial data science. So what I'm trying to say, with the RGS notebooks, we can integrate with the RGS Pro, and we can perform the analysis and view the results in a geographic context to automate your workflow. So we will use the machine learning algorithm called K-means clustering to analyze the population. So if you look at the screen here, we have mentioned about the skitlearn. So we'll talk about more in my next slide. So skitlearn is a statical data visualization Python library for predictive data analytics. Here we are talking about the population and the demographic analysis using machine learning. Okay, so demographic analysis has been raised due to over various reasons, such as rapid urbanization and extending longevity, which results in a higher demand for public services across the territory or across the country. Okay, so demographics are most important data points that are only the metric that truly reflects on the customer's age, gender, ethnicity, or income. So with this information, the governments could take a quick decision and planning. So what I'm trying to say here, we can use a Python or languages to analyze the demographic data. So the most popular computer languages to implement the machine learning models using the Python and R. So machine learning is based on algorithms that are to be able to improve their performances with each iteration. See, iteration process is very important. So the optimization of algorithms allows the machines to learn the process and to make the predictions at a faster than human can. Okay, so here K-means clustering is in the Python program, as I mentioned in my previous slide. It's a popular machine learning package from skitlearn. Okay, so skitlearn is a statical data visualization Python library for predictive analytics, which is exclusively we can use for statistical analysis for the demographic and as well as the population. Now the slides we're talking about, exclusively for the statistical organizations and population demographic. Okay, so here I mentioned the screen about the K-means clustering. K-means clustering is a popularized unsupervised machine learning algorithm, and that can be used with GIS, to analyze the population and distributions that used segmenting data into the clusters. So K-means is very, very important application, dividing the data sets into the number of clusters, similarities, and non-similarity groups or characteristics. Because for the population, for the total population purpose, we need to understand the similarities or different kind of similarities. So these clusters plays a role, using the K-means cluster as a unsupervised learning. So this technique can be used to identify the clusters and the data objects in a data set. So this tries to make implementing K-means clustering in a Python reasonably straightforward, even for novice programmers, even for the data scientists. Okay. Now here I'm talking about the data science and demographic analysis. Okay, so using this screen, what I'm trying to say, exclusively using this machine learning and deep learning techniques, we can visualize the census as well as the environmental or population demographic analysis. Okay, if you look at this right side screen, I mentioned a screen about, like the step one, we need to train the data, deep learning techniques, whatever I talked about that. We need to prepare the data, we need to train the data, and we need to train the model, and we can have a final model. Fine. So this is the basic requirement. So then output of this trained model, we can host this model with the machine learning models with the attributes, right? So this will become as a database. You can use it as a big data or whatever. So using that data analytics and using the deep learning techniques, we can visualize the population as well as demographic analysis. Entire, you can put this data into the attributes and push it to the web application server. It could be RGS RGS server, RGS online platform. Okay, so the left side screen showing here the spatial statistics. So it's a data dashboard based on the customer requirements. We can able to show the statistics analysis for the census or population and demographic status or economic status. Why the reason? This is very, very important. You know, the stakeholders who want to, you know, go for the big, for example, if any investors in the sector or whatever, when this demographic analysis and data science will give the quick results and the statistics to the investors probably, which I'm trying to say, you know, for quick decisions to set up any for any IT companies probably in the territory, anywhere in the country, you know, initially they will come with the budget. So they need to have this kind of a demographic analysis. This is exclusively useful for the business decision making as a statistical analysis. We can deliver, you know, deep learning technical techniques. So now, what are the challenges for the statistical organizations? So, I mean, for as I explained here, you know, like saving the time and money, labor, and environmental impact, and the speedy, timely information decision makers using this deep learning and you know, spatial data analytics and machine learning solutions. So it also increasing the efficiency and expanding the capacity, improving your accuracy, you can call, or engagement with the user community, or smaller budgets and revenues and staff, and growing, you know, the privacy conversion, and increasing the demand of better resolution and higher quality, you know, for long run. For long run, it is really very important for the stakeholders, expansions planning. This technological, you know, the idea of technology improving, you know, as I said, like census is one area. Now this is more advanced, you know, not just relying on only the census, going upon deep learning and techniques from the statistical organizations. It gives more value for the demand process. Okay, so thank you for your time today, and thank you too. Thank you, and would like to, and we can start for the questionnaire open sessions. And thank you for participating today and your valuable time. With this, we have completed all our presentations today, and so we are welcome to take some more open questions.
If you have any questions, please share it with us through the chat windows. We are open for the question answer session now.
And we are most welcome to take your questionnaires. We can also respond to your valuable questionnaires. Might be. Thank you very much. Thanks to all of you. Have you given your valuable time for us. Happy GS Day 2021. Thank you all of you.
Thank you everyone for joining the sessions. We assume that there are no questions. If there is any questions or queries, we can take.
Yes. Good afternoon. Yes. This is Wafa Al-Ghatem from Urban and Housing Lab, University of Bahrain. Thank you so much for amazing workshops actually that you provide for professional people or a little bit advanced people. And I have several questions regarding the different subjects, but I think the time is running. I might contact them in person. But most important things, just would it be possible running a workshops for basic informations for the students Can we invite you for the university, or can you host in the workshops, practical workshops for the university's faculty and students? That my questions briefly.
Yes, it is possible. We will
send us an email.
yeah, kindly you can kindly send us your email with your detailed requirement. Yes, definitely. Yes, we'll conduct the workshop for your requirement. We will do it.
Okay, thank you so much. We have two levels, like one is like basic knowledge and another is an advanced one. And regarding the other project, I will contact the peoples for the specific question. Thank you so much. It's a very lovely initiative from you to do such a things, and I hope that you keep it regularly from time to time to know about all these interesting projects running in Bahrain. So thank you so much.
Yeah, thank you so much. And I know that, I mean, you've given your valuable time from different organizations and governments. And we're also thankful to all our users and given your valuable time to, to host and to given our GIS Day 2021. And we are trying to move, moving as per the market trends and technological areas. We will try to give you more the solutions from Micro Center in terms of an including that ESRI integrated as our president explained today morning, integrated with the third party component. It could be the IoT, or it could be the even cloud platform, or even we are also willing to work even with the blockchain solutions as well, and cloud platform and IoT integration as well. So GIS is we are looking for GIS as one component. Now we can see as history has become very as an enterprise level. We can integrate different components because we also conducted previous sessions from Micro Center as we talked about, integrate with the IoT component as history explained today as like on geo velocity as a geo event manager, and we also have the capability, to go on. Yeah, we can do that. Yeah, thank you so much.
We're working right now with also a lot of government institutions, and like, for example, Ministry of Housing, Authority for Cultures and Antiquity, and also Authority for Planning, Civil Bureau, and they quietly like they would like to interpret all the data within the GIS, and maybe we can have some chat with you, meeting with you. How can we, help us in this or involve in such a things? And thank you so much for that. And talk to you later, maybe through emails.
Sure. Thank you very much. Yeah, thank you.
Thank you, everyone. And I hope in upcoming time, by God's grace, that if everything goes well, we will have more webinars. Instead of more webinars, we may have seminars. And also in the year 2022, we hope that we will meet you in person for the GIS Day 2022. So if you do not have any questions, we would like to end the session. Thank you, everyone, for joining. Have a nice day.
Okay, thank you.